real robot, just like this code. We always talk about robotics, robot, automation, and etc. But are we really know what really robotics is? I just want to give the definition of it. Robotics is an interdisciplinary research area which is an intersection of computer science and engineering, and it involves design, construction, operation, and usage of robots. The main goal of this robotics is helping and assisting humans in their daily lives and keep everyone safe. And there are three main aspects of the robotics. The first one is electrical, and the second one is mechanical, and the third one is programming.
In electrical part, so I'm gonna cover sensors, some of the sensors. First one is proximity sensors. I'm gonna cover two of them. The first one is photoelectric proximity sensor. There are emitter and receiver in this sensor. Emitter sends a beam of light to the receiver. When receiver cannot get this light, it means there is an object between them. So in this way, by this method, this sensor can detect the object between emitter and receiver. And second one is inductive proximity sensor. This sensor has a magnetic field. It can only detect the metals. When metal enter the magnetic field, it induces eddy current, and this eddy current occur voltage reduce in sensor. So this voltage reduce is trigger the switch. When metal exit the magnetic field, it's returned to original state. I guess you all know, but the transistors are used in electronics like switches. So when I say switch, it means really transistor. So second one is accelerometer. I guess we all saw this in homework or etc. There is a math shown in green. It is move with motion. When motion is occurred, it moves like this, and the distance between the plates is changing accordingly. So it is occur change in capacitance, and this cause change in voltage, and again triggers the switches. And there's a circuit board which is combined with magnetometer and gyroscope and accelerometer. Magnetometer can detect the direction you are facing to with using magnetic field on Earth, and gyroscope can detect the angular rate. And this whole package, this circuit board, allow us to detect our movement. So it is very useful and often used in robotics. So next one is touch sensors. First one, capacitive sensor. When we touch the surface, the distance between the plates is decreased. So it causes capacitance increase. So this causes change in voltage, again triggers the switches. And resistive sensor. When we touch the surface, it touches the sensor, let the current flow, and again, voltage is changing and trigger a switch. And next one is force sensor. There's a thin conductive wires on the string hook. When force is applied like this, the thin wires length is increased and the section areas is decreased, and this causes resistance increase. So in Wheatstone bridge, as we all know, the resistors are imbalanced. So we use Wheatstone bridge to detect the little changing in resistance. So we connect the string hook to the one of the resistors in the Wheatstone bridge to detect the little change in resistance. When force is applied, the resistance is changed, and we can detect the force by using this sensor.
Let's jump into the mechanical aspect of robotics. As you can see in the figure, we can divide mechanical aspect into two. Those are actuators and the basic structure. As you can see, it's a wide area that contains a lot of information. So I'll be focusing on engines in robotic industry. But first, let's talk about actuators. An actuator is a part of a device or machines that helps it to achieve physical movements by converting energy, often electrical, air, or hydraulic, into mechanical force. If we want to explain in a simple way, it's the components in any machines that enable movement. Sometimes to answer the question, what does the actuator do? The process is compared to the function of a human body, like muscles in a body that enable energy to be converted to some form of motions, like the movements of arm or legs. Actuator works in the machines to perform a mechanical action. There are various types of actuators, but for now, let's go to the engine part. Why motors? It's a good question. In robotics, the motors are heart of the system. And without the heart, no system can operate. If you want to make your robot as efficient as possible, it is really crucial that you have chosen the right motor type. Those are the most common used motors in robotic industry. Those are DC robots, stepper motors, and servo motors. A direct current, as I mentioned, DC motor is a type of electric machine that converts electrical energy into mechanical energy. DC motors take electrical power through direct current and convert this energy into mechanical rotation. DC motors use magnetic fields that occurs from the electrical currents generated. When electric current phase passes through a coil in a magnetic field, the magnetic force produces a torque which turns the DC motor. DC motors has two key components. Those are a stator and armature. Those are really important. The stator is the stationary part of the motor, while the armature is the rotation part of the motor. In a DC motor, the stator provides a rotating magnetic field that drives the armature to rotate. Simply by applying only 12 volts, we can make DC motor start rotating. They are using DC motors because it has high torque and high speed variation. Let's step up the stepper motor. Stepper motor is an electric motor whose main feature is rotating shaft by performing steps. As we activate winding steps by step in a particular order, a current flow will magnetize the stator and make electromagnetic pulse respectively that will cause propulsion to the motor. When we step to the working principle, it is electromagnetism. Once the supply is provided, the winding of the stator, then the magnetic field will develop with the stator. With that, the rotor in the motor will start to move with the rotating magnetic field of the stator. We can say that this is the fundamental working principle of this motor. Servo motors is the most used motor in the robotics, also in military systems. Let's find out what's so special about servo motor. The servo motor is a closed loop mechanism that incorporates positional feedback in order to control rotational or linear speed and position. That means that servo motors can minimize their error with this closed loop system. With minimized error, the result has a great precision. We can say that servo motor is a self-contained electrical device that rotates parts of machines with high efficiency. The servo motor is controlled with an electric signal, either analog or digital, which determines the amount of movements which represent the final command position for the shaft. And that's how servo motors work.
I will talk about the programming aspect of robotics. There are three types of robotic programs. First, there is the remote control programming. A robot with remote control programming has pre-existing set of commands that will perform only if it receives a signal from a control source, typically a human being with a remote control. Secondly, there is the artificial intelligence programming. Robots that use artificial intelligence interact with their environment on their own without needing a control source and can determine reactions to objects and problems they encounter using their pre-existing programming. Thirdly, there is hybrid programming, which is a form of programming that incorporates both remote control and artificial intelligence programming. Autonomous vehicles today are machines that contain hybrid programming until they reach the level 5 autonomy. Then they could be considered as artificial intelligence. Let's consider building a robot. What parts does a robot have and which programming languages are used today primarily? First, this robot would need electrical components like sensors, Ozan mentioned, to communicate with outside world and collect data. Secondly, we will need an embedded computer which processes data, runs the robot's application, and sends command to the third part, the microcontrollers, which control the motors, for example, a DC motor like Harold talked about, that makes the wheel of the robot move. When we look at the job offers involving robotics, we see that C++ and Python are the two languages that are mostly preferred. C++ is used for anything low level because of its high performance productivity rate. It needs much less quality hardware to work. Depending on the hardware, it can be 10 to 100 times faster than Python. So it's wise to use C++ where real-time constraints exist. Also, the language of a microcontroller is close to C++ and C. and therefore it is also wise to use C++ on this level. Python can be used for anything else that doesn't involve critical time constraints. Python is easier to use, so usually it allows to develop projects faster. Python is an interpreted language, so less time is spent on compiling the code and more time remains for testing and debugging, and those can be done without compiling while the program is running.
My friends already mentioned about the main aspects of robotics. What about robotics startup? Choose the three of them for you. First one is a no isolation. No isolation is a Norway-based startup, and it develops a robot called AV1, which gives support to isolated children, which affects long-term illnesses such as cancer, immunity system diseases, leukemia, as our previous slides mentioned at the previous presentations, healthcare technologies. The company aims that this robot could help to socialize the child and to take them in the real life. It has got a two-way audio system, which helps also give audio up and take the audio from their classmates. It has got one-way camera, and it is portable, and he said it has got avatar, as you see in there. And this robot actually helps kids respond to questions, hold conversations, go on school trips, and attend birthday parties. So I think it's very crucial to a child to interact with their friends, and the child could not interact their friends because of the health issues. This robot helps them, and this kind of robot called social robot. The social robot means that which interacts with people. And our second startup is Scaled Robotics. It's another crucial startup too. They state that 20% of the constructions are 20% of our recent constructions is because of the rework which they build what they build already, because it's malfunctioning. So this startup wants to prevent it, and they build a robot to prevent it. This robot has got cameras and light radar on it, as you can see in this presentation. It's a light radar representation of the robot. This robot collects the data and with its cameras and light radar, and it gives the model of the construction. Also can be used as autopiloted or the controlled as hybrid, as Caner mentioned. And it allows to determine wrongs in the constructions with its facial interface, which is supervised by the professional. And lastly, I want to mention related surgical systems prepare the surgeons this kind of operations, and they use robotical and VR-based infrastructure to prepare the surgeons. It has got two models recently. ROS one, which is a desktop, we can say. We are making the analogy to the computers, and a laptop model, which is a portable, and it has got that. And they aim to cut the risk of the heart actual patients and improve the quality of the robotical surgery. And as previous presentations mentioned, what tomorrow will bring to us, I want to mention that according to research, both in Europe and US, also it covers all around the world. I just wanted to give you a vision about the continent by continent. We are at risk at losing our jobs, especially at low educated level jobs, I'm going to mention. And this process is going to be about the next 10 years. It's very recent, and atmospheres from the automation are also that the pandemic has made more vulnerable. What are they? There are customer service jobs like market personnel, fast food sector, which is not need any intellectual background. It's automated job, and it can be converted to robotics actually. Also the transportation sector, it also can be automated because it's not need any professions actually at now. And the cargo sector, there's a lot of sector. Is the agricultural sector, also healthcare sector. Some of the parts of the healthcare sector, we can widen its range of the jobs who are in danger. The Forrester forecast that Forrester is a forecasting company, actually, a research company. The global workforce will be 29% of jobs to automation. They lose their 29% of the jobs to automation, while generating 13% new jobs for automation. So we can conclude that we need to upskill ourselves and retrain our workforce will be priority to the top of to-do list for business leaders in the years to come. So we can conclude that the old world is gone, which we live in, and pandemic accelerated that process.